take our average speed that we're going to run throughout the season. So it's 3 miles an hour. The max yield that we think we can actually, the combine can handle at that speed, which is going to be different depending on your combine and your header width. So say we do 220. Our header width, say we got an 8-row head. We're going to find our max flow, which is going to be 3 miles an hour times 220 bushel corn times 20 feet divided by 8.25, 1,600 bushels per hour. We're going to take that and multiply it by 0.8. We're going to get 1280. This is going to be the flow that we want to hit for our high flow. We don't want to run our high flow at this 1,600 because if that's the max that we think we can do, chances are, in our experience, we end up pushing the combine too hard and we put more corn out the back than we normally should. When we do that, it definitely screws up our calibration flow. So all the corn coming into the combine, we want going by that grain paddle. So we're going to shoot for this 1280. Now, how do we figure what speed to run when we're in that 1280? So first we want to figure out what the average yield of the place that we're going to combine. To do that, we're going to do our calculations out there, make our best attempt on kernel depth. And so even though that we need to calibrate for 220 bushel corn, because we think we'll hit that this year, in this field here we may only have 180 bushel corn, and that's fine. We take our bushels per hour, we multiply them by 8.25. So our intended target of 1280 times 8.25 equals 10,560. We take our 20-foot head, multiplied by the yield of the space that we're at. $3,600. And then we take the bushels that we need to get divided by our speed yield factor. Hit it right. It's 2.9333. So for all sake of it, we're going to run our high flow at 3 miles per hour. Okay, then determine our low flow. We're basically going to take that and divide it by 2. Our low flow is going to be at 1.5 miles per hour. Alright, and that gives us a good fluctuation between our high and a low flow to make sure on this graph here we're getting this point and this point far enough apart. This one's low enough to make a good line all the way across there. Alright. So then we'll have an old calibration number that shows up in the green star. Alright, it could be about anything, but say it's 740. Alright, we're going to take the old calibration number times the green star weight. So if we did load number 1 at 3 miles per hour, and say it says it's 5,000 pounds, and we say it's actually 4,300 pounds, we would do 740 times 5,000 divided by 4,300. We come up with a new calibration number of 860. Alright. Then what we recommend you do is go back into the combine, set your calibration number back to 740. Once you've entered the 4,300, it'll actually give you that calibration number. Set it back to 740 and do it again. And we do it 3 times in a row. And you'd come up with, you get the green star weight for both of these loads, the actual weight for both of these loads, and say we come up with some different calibration numbers. So in this case, then we'd take the 860, take the average of all of these, 860 plus 820 plus 880. Divide by 3. And we get an average of 853. Then we'd enter that 853 into our average cal load for those 3 loads. Then we would move on to our low flow. You're going to have a low flow compensation number in there. Probably pretty close to 1 to begin with. It'll always be pretty close to 1. And you do the same thing. We do a low speed, 1.5 mile an hour. Get our green star weight, our actual weight. We do that same division and say we get a new low flow number of 0.99. We go back, we enter the original old flow back in again, we do it all again. Say this time we get 0.98, this time we get 1.0. Alright, it comes up to an average of 0.99. That's the number we enter back in for the low flow. Remember, this is for Green Star yield monitors on pre-600 machines, ones that are only doing a high and a low flow. Alright, again, we'd always recommend you do the low flow.